All right, this is video 1 of the stoichiometry series. You are going to be needing your stoichiometry video packet, a calculator, and probably a notebook for this video. Okay, so in this video, we are going to be covering 3 things. We're going to talk about what stoichiometry actually is, the 2 different types of stoichiometry, and we're going to cover the steps for reaction stoich. Before we begin any of the stoichiometry, I would like you to please complete section A, which is the day 1 warm-up in your video packet. So please pause the video now, complete those 5 problems, and then hit play when you are done. Now that you've finished the warm-up for day 1, please check your answers with what I have on the screen here. Make sure that you got everything correct, and if you didn't, please figure out what you did wrong. You can pause the video now if you need to. All right, so we are going to get into what stoichiometry is. So if we break down the word stoichiometry, there are really 2 Greek roots that make up the word. The first one is stoichion, which actually means element in Greek, and the second part is metron, which means measure. So obviously, if we put that together, we are doing something with the measurement of elements, which is kind of true. So really what stoichiometry is in present day language is we are going to be doing a bunch of calculations that deal with the masses of reactants and products in a chemical reaction. So you should be able to, knowing only one measurement of the reactants or products, be able to determine how much of a substance is expected to react and how much is going to be produced. There are 2 different types of stoichiometry. The first type is called compound stoich, and you actually already have mastered this. I call it mole conversions, but it's actually a form of stoichiometry called compound stoich. So you will be using this information, your expertise on this, to help you with the second type of stoich, which is reaction stoich. So we are going to be doing 2 example problems today in order to go through the different steps of reaction stoich. I would highly suggest as we go through each step, please write the steps down in your notebook so that when you are doing the extra stoich problems, you have the steps at your fingertips. So the first problem we are going to do, and it's the same in your packet, it says hydrogen gas reacts with oxygen gas to produce water. If 45.5 grams of oxygen gas is used, how much water will be produced? The first step, and I would like you to write this in your notebook, feel free to pause the video if you need to, is to write out the chemical equation and balance it. So, looking at what I was given, hydrogen gas reacts with oxygen gas to produce water. I know hydrogen gas is H, and I know that hydrogen is diatomic, so that is why it is H2. Oxygen gas is O, and I know oxygen is also diatomic, so that is why I put the 2 here. And then those go to produce water, which is H2O. And if you didn't know what water was, you could do the crisscross. Hydrogen is a +1, oxygen is a -2. When you crisscross, you should get H2O. And then when you balance it, you should get a 2 in front of the hydrogen and a 2 in front of the water. The second step now is to determine from the problem what you are given, which is what you are going to be starting with in the stoich calculation, and what you need to figure out, which is what you are going to be ending with in the stoich calculation. So in the problem, it tells us that we have 45.5 grams of oxygen gas. So I usually like to write out or underline it in the question that I'm starting with 45.5 grams of oxygen gas. I then need to find, it says in the problem, how much water will be produced. And it's always going to be in grams. I'm never going to have you stop in moles. So we need to find grams of water. This is going to be really helpful when you are doing your Stoic problems so that it is very clear to you where your starting point is and where your end point is. Step 3 is to set up dimensional analysis. I told you it's coming back. And we are going to put the value that we were given, so the starting value, in the upper left-hand box. And it's really important that we put a label on it. So let me show you what I mean by that. So I set up my dimensional analysis. I put in what I was given in the upper left-hand box. And when I say that you need to use labels, not only do you need to put the unit on the number, but you also need to tell me what compound or element you are working with. So this is 45.5 grams of oxygen gas. So you need to label that. If you just put 45.5 or just 45.5 grams, that could be referring to any of these three compounds. And so it can get a little confusing when you start to switch from oxygen to water. So you need to make sure that every single number you write down, you not only have a unit on it, but you also tell me what compound you are referring to. Step 4 is to convert the mass into moles. And you know how to do this because this is just a simple mole conversion. So looking at O2, right, we have grams of O2 in the upper left-hand box, which means we need to do grams of O2 diagonal so that the grams will cancel out. And we need to figure out how many grams are in 1 mole of oxygen gas. So I know that one oxygen atom weighs 16 grams. And since I have 2 of them, I just multiply 16 times 2 to know that there's 32 grams of O2 in 1 mole. You've done these before, you're going to just keep doing them again. They're pretty simple. Step 5 then, this is new. We are going to now convert from the compound we are on to a new one. So we are going to be using the balanced equation to determine something called the mole-to-mole ratio. And we are going to use this ratio as a conversion factor to convert from moles of one substance to moles of another. So a mole-to-mole ratio is the ratio between the amounts in moles of any two compounds in a chemical reaction. This is why it's so important that you guys know how to write out an equation and balance it, because if you get this portion wrong, you are going to get the wrong answer. So for instance, if I have this balanced equation here, we are going to use the coefficients in front of each compound to find the mole-to-mole ratio. So for instance, for every 2 moles of iron oxide I put into a reaction, I'm going to get 1 mole of iron out. Likewise, for every 2 moles of iron oxide I put in, I'm also going to get 3 moles of carbon dioxide out. Likewise, for every 1 mole of carbon I put in, I'm going to get 1 mole of iron out. For every 1 mole of carbon I put in, I will also get 3 moles of carbon dioxide out. Likewise, for every 2 moles of iron oxide I put in, I need 1 mole of carbon also put in. And for every 1 mole of iron that I get out, I should be getting 3 moles of carbon dioxide out. So we can use these coefficients as ratios, and then we can use those as a conversion factor to go from reactant to product, product to reactant, reactant to reactant, or product to product. So in the question or in the problem that we are working with, we need to go from oxygen gas to water. So since I have moles of oxygen up, I need to do moles of oxygen down. So I refer to my balanced equation and I see that there is a coefficient of 1 in front of my oxygen. So that is why I put a 1 mole of oxygen down. Then to get to water, we need to look at how many moles of water I have. The balanced equation tells me that for every 1 mole of oxygen, I have 2 moles of water being produced. So that is why I put a 2 moles of water above. So this is equal to 1. This is a conversion factor. For every 1 mole of oxygen gas, I make 2 moles of water. The next step then is just to do another simple mole conversion, converting the moles of the new substance into grams of that substance. So we are now in moles of water. So we need to convert moles of water into grams. So since I have moles of water up, I need to do moles of water diagonal down. And I know for every 1 mole of water that there are 18 grams. 1 oxygen at 16, 2 hydrogens each at 1, 16 plus 2 will give me 18 grams. So that's another simple mole conversion, moles of water into grams. The next step is to make sure that all your units cancel out and that you are left with the grams of the substance you were asked to calculate. So for instance, we were asked to find grams of water. We need to go and make sure that all of our units cancel out and that we are left with grams of water. If we are not, if our units aren't canceling out, then we did something wrong. We have to go back and fix it. So I have grams of oxygen up, grams of oxygen down, those cancel out. Moles of oxygen up, moles of oxygen down, those cancel out. Moles of water up, moles of water down, those cancel out, which means I'm left with grams of water, which is what I want. So we're good. The last step is to solve and to remember to put units and labels on our answer. So we would go through and do 45.5 times 1 times 2 times 18 divided by 32 divided by 1 divided by 1 to get an answer of 51.2 grams of water. It's extremely important that you put a unit and a label on your answer. And that's it. That's reaction stoich. Shouldn't be as scary as I talked it up to be, but you should be prepared to understand this with a couple of my example problems. All right, now we're going to go through example problem number 2, which is also in your packet. It is on page 2 of your video packet. And this time, every time I go through the next step of the problem, I would like you to pause the video on the step slide, and I want you to try that step on your own before hitting play again so that I can show you how you should have done it. Hopefully, after this problem, we'll be able to do some problems on our own with the help of the steps. So the second problem states 35 grams of propane, and you don't know what propane is yet. When we get to organic chemistry, you will, but right now you don't, which is why I gave you the formula, reacts with oxygen gas in a combustion reaction. How much water is produced? Now the first step is to write out the chemical equation and balance it. So please pause the video, try to write out the chemical equation, predict the products, and then balance. Hit play when you are done. So you should have gotten an equation that looks like this. We have propane, which is C3H8, reacting with oxygen gas, and oxygen is diatomic, so you should have put O2, going to form carbon dioxide and water. I know that these are the products because it says that it's a combustion reaction. Can also tell because this is a hydrocarbon reacting with oxygen gas. And then when you balance it, these are the coefficients you should get. Step 2 is to determine from the problem what you are given and what you need to figure out. So please pause the video, see if you can decipher what you are starting with from the problem and what you need to figure out. Hit play when you are ready. So you should have found that we were given 35 grams of C3H8 and we need to find grams of water. It says it right here and right here. The next step, step 3, is to set up dimensional analysis and put the value given in the upper left-hand box with a label. So please pause the video, try this for yourself, and hit play when you are finished. So you should have put 35 grams of C3H8 in the upper left-hand box of your dimensional analysis. This is the value we were given. This is the value that we are going to start with. Notice this is the only number given in the problem. Where else are you going to start? Step 4 is to do a simple mole conversion and convert this mass that we're starting with into moles. So please pause the video, do the simple mole conversion, and then hit play when you are ready. So you should have found, since we have grams of propane up, we need to do grams of propane down. And to do the mole conversion, you find out how many grams are in 1 mole of propane. To find how many grams are in 1 mole of propane, you should have found that 1 carbon weighs 12 grams, and we have 3 of them, plus 8 for each of the, each hydrogen weighs 1 times 8 would give you 8. You should have gotten a total of 44 grams. So we have grams diagonal, so they cancel out, in 1 mole of propane. The next step is to use the balanced equation to figure out the mole-to-mole ratio so that we can go from propane into the substance that we are trying to get to, which is water. So please pause the video, try this for yourself, and hit play when you are ready. So you should have found, we have moles of propane up, we need to do moles of propane down, and from the equation we know we have 1 mole of propane. We are going to water, and when we go over to the water portion of our equation, we see that for every 1 mole of propane, we are going to make 4 moles of water. So that is why we put 1 mole of propane down so that these cancel out, and the 4 moles of water up. The next step is to convert moles of this new substance, in this case the water, into grams using another simple mole conversion. So please pause the video, try this out, and hit play when you are ready. So since we have moles of water up, we need to do moles of water down. And when we are converting moles into grams, we always have to figure out how many grams are in 1 mole of that substance. So that's why we put 1 mole down here. And we know that there are 18 grams in 1 mole of water, which is why we put that here. If you don't know how we got the 18 grams, 1 oxygen weighs 16 grams, each hydrogen is 1, so that would be a total of 2. 16 plus 2 will give you 18. The next step is to make sure that all your units cancel out and that you are left with the amount in grams of the substance you were asked to find. Please pause the video, make sure all your units cancel out, and then hit play when you are ready. So looking at our dimensional analysis, we have grams of propane up, grams of propane down, those cancel out. We have moles of propane up and moles of propane down, those cancel out. We have moles of water up and moles of water down, those cancel out. And we are left with grams of water, which is what we wanted, so we are good to go. The last step is to solve, and you need to remember your units and your label in order for your answer to be correct. So please pause the video with your calculator, solve this problem, put the correct unit and label on it, and then hit play when you are ready. So you should have plugged into your calculator 35 times 1 times 4 times 18 divided by 44 divided by 1 divided by 1 to get an answer of 57.3 grams of water. If you do not have this label, that is going to be points taken off of a quiz, lab, assignment, or whatever it may be. If you did not get this answer, please try plugging it into your calculator again. And if you're still not getting the correct answer, please ask another person around you to see if they can help you out. Now that we've gone through both of the example problems, please in your packet, try to complete section B which is stoichiometry practice problems. There are 5 of them in your packet for you to try. There are answers on Google Classroom. Just search for the answer key that says section B, and all of the work and everything should be shown for you on those answer keys. If you don't get the answers correct, please try watching the video again and going through the steps with the video in order to figure out where you are going wrong. And then when you finish that, there should be another section, section C, which has extra practice problems. In this case, it is predicting products, balancing, and determining the type of reaction for you to try as well. And those answers are also on Google Classroom. Just search for the section C answer.